Hi, everyone, and welcome to Unit 4, Lesson 7. And so what I'm going to show you, we're going to take the next step in factoring these trinomials. And so again, just as a review, what we've been learning about these parabolas or about these quadratics is we've been learning about the different forms, the factored form versus the standard form. We've learned that you can go from factored form, so from this form, you can go to standard form using FOIL, and that's where you go first, outer, inner, last, and so you can go, you convert it, and that would give it to you in standard form. And then starting last lesson, what we're learning how to do is to go the other direction, and we call that factoring, is going from standard form to factored form. And it's a little bit more involved, and that's why it's going to take us a few lessons to get there. So we did our first lesson, and our first lesson is what I call step number 1, and that's just removing the greatest common factor. And so that's what we did in the previous lesson. So if I gave you something like this, now I know this first one actually isn't a quadratic, but I'm just going to show it to you. Let's just say that it was y equals 4x plus 10. I know that that's a linear equation, but I could write that. I could pull a common factor out of it and say, well, I can see that 2 goes evenly into both of those numbers, so it's 2 times x plus 5. So that's what we call removing the greatest common factor. Well, let's try it for an actual quadratic. So if I had this quadratic, or this, and I know it's a quadratic because it's got the squared term with the x, well, I could pull out a common factor. Well, I look at the numbers, and I see 3, 21, and 54, and I notice that 3 goes evenly into all of those. And so watch what I can do. I can now write it as 3 times x squared minus 7x minus 18. Okay, and so 3 goes evenly into each of those numbers, and so we've removed 3. So the first step is removing the greatest common factor, and I just want to emphasize that. That's what the last lesson was about getting used to removing the greatest common factor. Okay, now what? Well, here's the question is, how do we go from x squared plus 9x plus 20 to something that looks like this? So, here it is, there it is, y is equal to this. That's in standard form. And then how do we go to putting it into factored form? And we want to get to factored form because factored form gives us the zeros, gives us the, where the parabola crosses the x-axis. So, maybe it's like this. So it gives us those 2 points really easily. And so that's why this factored form is so nice. And so, but how do I get those numbers? How do I go from here to here? That's today's lesson. And today's lesson is going to focus on what we call the simple trinomials. Okay, so here we go. We're going to do something called Xbox factoring. Okay, now it's called Xbox. I know that's a bit of a play on the famous gaming system, but we use it in math as well. So here's what Xbox factoring is. So what we're going to do is we are going to take a trinomial. Okay, and a trinomial is just it's got 3 terms in it. Now, I'm going to put in brackets here. It's a quadratic. Obviously, this one has an x squared term, an x term, but it doesn't have to be a quadratic. But essentially, that's why we're using this. So we're going to take a trinomial like in standard form. So there it is. There's my quadratic in standard form. And what you do, what the Xbox is, notice that within a quadratic, the number that goes in front of the x squared term we call a. The number that goes in front of the x term is called b. And the number that does not have an x, it's called a constant term, is called c. So if it was, I'll just show you, if it was this one, if it was, I don't know, 2x squared, the a would be equal to 2. And let's say it was minus 3x, the b would be minus 3, and then plus, I don't know, plus 17, the c would be 17. Okay, so those are examples of a's, b's, and c's. Okay, well, just so you know that for today's lesson, we're going to emphasize, I'll just say today, all we're going to do is a equal to 1. So just tomorrow or in the next lesson, we'll do a's of greater than 1. But for today, we're going to make our life a little bit easier by saying, well, let's pretend that the a, or the number that goes with the x squared term, is always 1. Okay, but here's how you use an Xbox. You put a little X on your page, and then what you do is you multiply A times C, and you put it up in this part of the X. You take the B term, and you put it down here in the bottom part of the X. And then what you're going to do, and so I just say that here, place the product of A and C at the top of the X, place the coefficient B at the bottom of the X, and then what you're doing, here's the whole key, is you're trying to fill in a number here and a number here, and here it is. Those two numbers have to multiply to give you the numbers up, the number up top, and they have to add to give you the number down below. That's your whole goal of the Xbox, is to find two numbers that when multiplied together give you the same as this A times C up here, and then add to give you B. Okay, well, let me show you. I know that's kind of I'm sure you're kind of confused by that. Let me show you what I mean. So if we had this quadratic, y is equal to x squared plus 9x plus 20. The whole idea here then is and remember I said for today we're going to work with a is equal to 1. So look at this. A is equal to 1. It's going to make our life a little bit easier. B is equal to 9, and C is equal to 20. So look what I did. In the top of the X box, I did A times C. So 1 times 20 is 20. In the bottom of the X box, I just put the 9. And now what I'm looking for is I'm looking for two numbers that multiply to give me 20, and the same two numbers will add to give me 9. And so obviously the answer is here, but their numbers are 5 and 4. 5 times 4 is 20. 5 plus 4 is 9. And then here it is. The nice thing is that once you're there, basically, as long as A is equal to 1, look what you get to do. You can now write it in factored form. So it'll be y is equal to x plus 5, x plus 4. There it is. That's how you factor, okay, by using this Xbox. And I'll just show you, just to prove to you that these two are the same. Remember that we can go back the other way by foiling it. Look at this. If I were to foil this, I'd go first, x times x is x squared. Outer, x times 4 is 4x. Inner, 5 times x is 5x. And then last, 5 times 4 is 20. And look, we have two like terms, 4x and 5x, so that's 9x plus 20. There you go. It's the same parabola. So there's the Xbox. Well, let's practice a few of these. All right, so here we go. Let's do this one together. So I want to factor this. I want to write it in factored form. So here we go. I'm going to create my Xbox. And I notice that there it is. There's no number there, which means it's 1. So A is 1, B is 12, and C is 35. So I do, in the top of the X box, I do 1 times 35. Well, that's 35. And in the bottom of the X box, I put a 12 because that's the B term. So here we go. I'm going to look for two numbers that will multiply to give me 35 and add to give me 12. And so really what I do is I focus in on the top number because there's only a limited number of things that will multiply to give you 35. And so I say right off the bat, well, 1 times 35 would give me 35, but clearly 1 and 35 does not add to 12, so I'm not going to do that. Okay, how about 5 times 7? Ooh, there it is. So look at this. 5 times 7. Oh, 5 plus 7. Oh, there it is. And so in factored form, this is y is equal to x plus 5, x plus 7. There it is. That's how you factor. That's how you go from a standard form to a factored form. Now, again, I'm going to emphasize that it's a little bit easier because a is equal to 1. And in the next lesson, I'll show you the next one. But let's try a few more. Okay, so here we go. Let's do these ones. So I look and I'll create my X box. X squared minus, so yeah, so here we got some negatives now, but we're still okay because look at this. Here, I'm just going to move my X box down just a little bit here. Okay, so I just want to emphasize this. So look at this. A is equal to 1. That's the number out front of the X squared. B is equal to negative 1. And C is equal to negative 72. So A times C is negative 72. So that's what I put in the top of the X box. In the bottom of the X box, I put negative 1. All right, so I'm looking for two numbers that multiply to negative 72 and add to negative 1. Well, one thing right off the bat is that in order to multiply to negative 72, it has to be a positive and a negative number. I just want to emphasize that. So look at this. One thing I'm going to do right off the bat is I'm going to say, well, it has to be a positive number times a negative number. And the reason why I know that is that if it was two negative numbers and you multiplied them together, you'd actually get a positive. So I know it's going to be positive and negative. The other thing I know right off the bat is that because these two numbers have to add to negative 1, I know that the negative number is going to be bigger. Okay, well, all right, let's start thinking about numbers that multiply to 72. Well, 1 and 72 works, so I could do 1 and 72. They multiply to negative 72, but look, they add to negative 71. That's not right, so I'm going to undo those. Okay, I'm going to undo those, and okay, what about 2 and 36? So look at this. Plus 2 and minus 36. They multiply to 72. But look, when I add them up, they add to negative 34. Okay, so no, they're not going to work either. Okay, so I'll take them away. Well, right away, I think I know what it is. It's going to be plus 8 and negative 9. 8 times 9 is 72. Beautiful. And look, plus 8 and minus 9, good, adds to negative 1. So there you go, and you come down here and you get to write y is equal to x plus 8, x minus 9. We're done. Okay, let's try a couple more just to give you some examples. Here we go. I'll do my X box here. In fact, I'll do my other X box when I'm ready. So here we go. A, now I know this is A's, but it doesn't really matter. I can still say A is equal to 1, B is equal to negative 13, and C is equal to 36. Okay, so 1 times 36, it goes up here, and then the negative 13 goes down. All right, let's give this a shot. Now, again, let's kind of go into it with a plan. I know that they've got to multiply to a positive number, right? That 36 is positive, but they've got to add to a negative number. So the only way you can multiply to a positive number and add to a negative is they both need to be negatives. They both need to be negatives. Okay, so here we go. How about we try -6 and -6. -6 times -6 is definitely 36, but they only add to -12, so that doesn't work. Okay. How about 3 and 12? -3 and -12. So 3 times 12 is 36, but that adds to -15. Okay, so that doesn't work. All right, so how about -4 times -9? 4 times 9, -4 times -9 is definitely 36, and -4 minus another 9, oh, there it is, they add to -13. We got it. Okay, so your answers would be y is equal to x minus 4, x minus 9. Okay, let's try one more here, and we've got a is equal to 1, b is equal to 1, and c is equal to 6. So 1 times 6 goes up here. 1 times 6 is 6. B is 1. Okay, so I need two numbers that multiply to 6 and add to 1. Okay. How about if we do... well, again, let's start with a plan in mind. Is if we did, you know, maybe if we did a -2 times a -3, well, that's going to multiply to 6. But do you notice that it's not going to add to the 1? Okay. So that doesn't work. And the one thing I notice here is that in order to multiply to 6 and then add to 1, one of them is going to have to be positive and one of them will have to be negative. Like obviously, so if it was -2 and +3, then that would add to 1, but notice that that would multiply to -6, so that's not going to work. And so I think that what you're seeing here, let's try a couple more. How about 1 and 6? Well, that multiplies to 6, but it adds to 7. And if you made it -1 and -6, it's going, because that would multiply to 6. And so I think what you're seeing here is that this one does not work. And so this one, you would say there are no factors. There are no factors. So you can get situations where it's not going to work. Okay. So for homework, I'd like you to practice some of these. Now, the nice thing is so I've asked you to do 4, 6, 8, and 12. Here they all are, 4, 6, 8, and 12. The answers for them are right here. And so you can quickly double check whether or not your Xbox worked or not. Now, the one thing I'll say here, just for 6, even though it has a single block there, really that block is going to be two numbers. It's going to be x, plus or minus something else. So it's just, even though it shows a block, please know that it's a bracket. And again, really all you have to do to solve that one is just to use your Xbox, and they've given you one of the factors, and so you know that one of your, in that particular one, that one block is, one side of it is 3. And so here, I'll just write it, I'll do that one for you. You put a 24 there and an 11 here. You're looking for two numbers that multiply to 24 and add to 11, and they've told you that 3 is one of them. And so hopefully you can find the other one, and that's what goes there. Okay, so this is just nice. It's a good practice setting up your Xbox, finding the two numbers. Okay, good luck with that, you guys, and let me know if you have any questions.